Hello, welcome to NeoScribe. NASA plans to share the cost of the development of at least one commercial space station in the near future. This is because the current administration wants to end support of the International Space Station and facilitate the transition to the commercialization of low Earth orbit by 2025. Per the NASA Transition Authorization Act of 2017, the vision of this transition is to create a low Earth orbit, non-governmental human spaceflight enterprise where NASA is just one of many customers. There are at least 3 companies who are developing commercial space stations. There's Bigelow Aerospace, Axiom Space, and Orion Span, which I imagine will all compete for NASA funding at some point. Today, we're going to cover Bigelow Aerospace and Axiom Space. I already did a video on Orion Span, so if you want to check it out, there's a link in the description. Robert Bigelow started out developing commercial real estate in the late 1960s, including apartments and hotels, and founded Budget Suites of America in 1987. In 1999, he founded Bigelow Aerospace, which specializes in expandable space modules. NASA engineers first came up with the idea for expandable structures for use in space back in the 1960s. Then in the 1990s, NASA worked on the Trans-Hab project, which was meant to be an expandable habitat module for the ISS. But Congress canceled the project in 2000, and NASA licensed the relative patents to Bigelow Aerospace. Then Bigelow expanded on the technology and launched the experimental habitats Genesis 1 and 2 in 2006 and 2007. Genesis 1 and 2 remain in orbit today, testing the long-term viability of the technology. Then, in 2016, they launched the Bigelow Expandable Activity Module, or BEAM, to the ISS, where it's currently being used as a storage area. Bigelow modules consist of multiple layers of Vectran, which is a Kevlar variant spun from liquid crystal polymers. The modules are also coated with micrometeorite orbital debris shielding, protecting the structure from space debris traveling at 10 kilometers per second. Surprisingly, Bigelow's modules hold up to space debris impacts better than ISS modules. Bigelow conducted a simulation of micrometeor impacts that completely punctured ISS skin samples, where those same simulations only went half through Bigelow's skin. What's really cool about these modules is that the atmospheric pressure of the Earth is enough to fully expand them, and when the modules reach orbit, nitrogen and oxygen tanks release a breathable mix of air and inflates the modules to 40%, and then the air expands the module the rest of the way. So now, Bigelow is developing the B330 inflatable space habitat in North Las Vegas, Nevada. The B330 is a multi-purpose module that will be used for industrial and scientific purposes as well as for space tourism. The design of the B330 was based on NASA's Trans-Hab design, so the B330 will be able to sustain a crew of 6 astronauts and measures over 13 meters long and over 6 meters in diameter and will weigh between 20,000 and 23,000 kilograms. But it's the volume to mass ratio that makes this technology exciting. At 330 cubic meters, the B330 will have 210% more habitable space than the ISS Destiny module, but only has 33% more mass. Inside, the B330 will feature a zero-G toilet, semi-private quarters, exercise equipment, a food storage and prep area, and a personal hygiene station. And in 2021, Bigelow plans to send 2 B330 modules that will link together to form the commercial space station called Alpha Station. The Alpha Station will be available to international space agencies who want to do research and conduct spaceflight training, to corporations for various industrial purposes, and for space tourism. And the station will be marketed and operated by a new company called Bigelow Space Operations, founded in February of this year. Based on estimates in 2013, the price for leasing 2 months of 110 cubic meters of the Alpha Station will be $25 million, not including launch cost, which will be around $26 to $36 million depending on the launch vehicle. Another interesting thing is that similar to sports stadiums, the naming rights will be up for sale at a cost of $25 million per year for full naming rights, and $12.5 million for the naming rights of one of the B330 modules. So someday we might refer to Bigelow's Alpha Station as something like the Coca-Cola space station or the AT&T space station. But anyways, Bigelow is already planning beyond the Alpha station, and they are developing something truly spectacular. Enter the B-2100, aka the Olympus. The Olympus will have a pressurized volume of 2,250 cubic meters, almost 2.5 times the volume of the International Space Station. Look how massive it is. Imagine that in space. Now you're looking at a mock-up, not an actual prototype, but it's still really cool to see. Now look at this picture with the table for scale. Now look at this photo. It's incredible how big this will be. The massive module will be almost 18 meters long and over 12 meters diameter. Until we actually see orbital construction technology in space, launching a structure like this would not be practical without expandable module technology. Even though the module is expandable, it's so big that the only launch vehicles that will have both the payload capacity and the fairing size in order to launch it will be the Block 2 version of NASA's SLS and SpaceX BFR. And Bigelow hopes to seriously start developing Olympus 6 to 10 years from now. Alright, now let's move on to Axiom Space. Axiom Space was founded in 2015, and their vision is to make living and working in space commonplace as a means to a robust economy in low Earth orbit. The strength behind Axiom Space is the people in the organization, starting with its founder and CEO, Michael Suffredini. Suffredini has over 30 years of experience in human spaceflight and served as NASA's ISS program manager for a decade prior to his retirement. And then Axiom's chairman, Cam Ghaffarian, founded Stinger Ghaffarian Technologies, or SGT, in 1994. And SGT is NASA's second largest engineering service provider. And then Stephen Altimus of Axiom's engineering department is a former deputy director of NASA's Johnson Space Center, which oversees human spaceflight plans and programs for NASA. And this experience goes on throughout the entire company, and their team as a whole has been involved in every ISS mission since the beginning of the program. So in other words, Axiom Space knows their stuff. And so they plan to attach a module to the ISS in 2019 and to start sending customers to it by 2020. And they hope to have their space station ready by 2022. Although Axiom won't be using exciting expandable module technology, their space station will be amazing in other ways. Axiom Space Station was designed by French designer Philippe Starck, a legend in modern design. And the station will have an initial configuration that will be able to sustain a crew of 8, consisting of a node, a habitation module, a research and manufacturing module, and a window observatory. More on that in a little bit. Eventually, Axiom will add to this configuration to allow for it to be a standalone space station. The additions will allow the station to sustain a crew of 16 and will include a research and logistics module, a power and thermal module, and a second habitation module. Speaking of habitation modules, look at this rendering of Axiom's habitation module. It looks awesome. It's sleek, warm, comfortable, and inviting with padded walls, hundreds of LEDs, and a massive window. A stark contrast compared to the industrial metallic interiors found in the ISS. But the most spectacular part of the station, however, is that it will have the largest window observatory ever constructed for space. Look at it from the outside of the station. That looks so cool. And then I recorded this from Axiom's website where you can scroll around and see what it will be like in the observatory. Imagine being up there, immersed in space above the Earth. That would be so extraordinary. But that extraordinary view will cost an extraordinary price at $55 million per person for a 10-day stay at the station. And that includes a 15-week training experience and also includes launch costs. Alright, wrapping this up, there's Bigelow Alpha Station with 660 cubic meters of habitable space, capable of sustaining a crew of 5 to 7, and a price estimate of $25 million to lease 110 cubic meters of the station for 2 months. I couldn't find specs on Axiom Station, but it's going to be pretty big considering it has a habitation module, a research and manufacturing module, and a window observatory, and supports a crew of 8. But we know that the price is estimated at $55 million for a 10-day stay, including launch costs. Assuming the launch costs will be similar across the board, let's subtract $30 million from $55 million, and that leaves us around $25 million for the cost to access the station for 10 days. Finally, there's Orion Span's Aurora station, which will initially only have 160 cubic meters of habitable space, but it'll be able to sustain a crew of 6. What Aurora lacks in size makes up for in price at $9.5 million for a 12-day stay. Anyway, I imagine all 3 of these companies will compete for NASA funding if and when NASA commits to help fund a commercial space station. And hopefully we will see a commercial space station in the next decade, serving as the platforms to finally have a low Earth orbit, non-governmental human spaceflight enterprise. Alright, that's all I have for now. I hope you enjoyed your journey. If you did, please leave a like and subscribe. I am NeoScribe, and I'll see you on the next journey. Hey guys, I hope you're enjoying this series so far. I'm rooting for all 3 of these companies, and I hope there will be enough demand in the future to sustain all 3 of these space stations. If you're wondering why I didn't include the Gateway Foundation, it's because this series is focused on the near-term future to around 2025, when NASA will likely transition away from the ISS. If you just stumbled on my channel, this is part 2 of a 4-part series about the commercialization of low Earth orbit, so if you want to check out part 1, look for this thumbnail on my video list. But I want to hear from you guys. Which space station would you like to see, or which company do you think has the best shot of actually launching a station? Let me know in the comments. And now, I'd like to thank Sasha Parkovic, Suzanne Bostacoti, Tao Hu, and Jonathan Olson for pledging their support on Patreon. You guys are so awesome. And if you connect with my content and want to help support this channel, there's a link to my Patreon page in the description. You can pledge as little as $1 per month. Every bit helps. Thank you all so much, and I'll see you next time.